Hi, I'm Matt Denesuk, and I'm the Senior Vice President for Data Analytics and Artificial Intelligence at the Royal Caribbean Group. And a little bit about my background. That's what I do right now. Before coming to Royal Caribbean, I was a founder of a startup called Noodle.ai, which was an AI as a services company, which is still running, based in California and in India. And before that, I was the Chief Data Science Officer at General Electric and ran data science programs and a center of excellence across all of their business units. And before that, I spent over a decade in IBM research, kind of plumbing the depths of technology and analytics and AI there. So that's my background. And today, I want to talk to you about something a little bit different, about a science of business, and how what some of us have been calling enterprise AI over the last several years or so is really about enabling such a science of business. So I was in a meeting some time ago with the CEO of a Fortune 50 company, and the topic of whether we could develop a science of business came up. Now, this wasn't a discussion about data science or AI. It was broader than that. Okay, and the statement made by this business leader that there's no such thing as a science of business, that there never has been or ever will be, really stuck in my mind. And I didn't buy that, and I set about trying to understand what a science of business really would look like, and who would create it, what kind of people would create it, what kind of measurements and tools would they need, and so forth. So it kind of started me on that path to try to figure this out. Now, these enterprise AI problems that we're talking about, the problems that a science of business would have to address, are basically about how traditional enterprises, and we'll get more on what we mean by that later, but how traditional enterprise interact with the world. So in the world, you have lots and lots of people, each one's an individual with all kinds of complicated emotions and needs and desires and so forth. And you're trying to connect in some way with them via some complex business process. Let's say it's involving many feedback loops in a marketing process with pricing and purchasing decisions and putting things in front of people and so forth. And all of this is happening in a noisy, changing world that adds all kinds of exogenous influences to the problem. And then to top it all off, you've got really bad data typically. You have data generally that just happens to be lying around. It's data that was collected for some other purpose, for compliance, for financial reporting, whatever, but it's not the data that you would have asked for if you could ask for any kind of data. So this is really a complex, ill-posed problem. Now, let's compare this to a much more common problem that you hear often when people talk about AI. It's a much more simple, and I would argue solved problem, right? Computer vision. So you have an image and you want to say, what's in that image? It's a cat, it's a dog, whatever it is. It's a simple problem statement, a very clear idea of what success looks like. And you have awesome data. You've got tons and tons of perfectly labeled, correct examples that were generated just for you. They were generated for the purpose of building the model you want to build. It's exactly what you need. So you run it through an off-the-shelf deep neural network and out pops a near perfect classifier, right? So that's what we're not doing, but that's what a lot of people think of when they think of AI. Now, back to the science of business, I'd like to pose an hypothesis and then explore it through the next several slides and so. The hypothesis is that adoption of a sustained, truly scientific approach toward understanding business processes and the environments in which they work will lead to a dramatic and majorly and continually improving performance of traditional enterprises. So in other words, a science of business, right? And the next 10 minutes or so, we'll try to unpack what we mean by this and how to make it happen. So first, let's step back a bit and say what we mean by science. First of all, if we're going to talk about a science of business, what do we mean by science? Now, there's lots of noise, especially lately, around the concept of science these days. Everybody's claiming to be doing science-based this and science-based that. They say, I'm science-based and you're not, and so on and so forth. But let's be more rigorous and not really pay attention to the latest stuff that's going on. Amongst scientists, science is pretty much seen as a systematic way to organize knowledge, and in a way that's testable, that's explanatory, and ultimately predictive of how the world works. And of course, if you understand and you can predict, you can generally get to prescription, meaning you can change how the world works to suit a particular purpose. And that, of course, gets into engineering, which is basically applying mature science to design and build things. Right now, the engineering side of things we'll save for another day, but let's stick with the science part. So I'm sure you've heard and seen many representations, even back to your grammar school or high school days, of the scientific method. Now, a common representation from Wikipedia is shown here. Now, anyone who's worked doing science, which I actually did many years when I gave my background, I was a professor for a number of years at a university worked as a scientist for a while as well. And anyone who's actually worked doing scientist will tell you that the actual process of doing science doesn't fit so neatly and cleanly into this kind of linear flow here. But the representation does capture the key elements and how they kind of interact with each other pretty well, I think. So it typically starts with some kind of question or need. Up on the top there, it says observation question. Typically starts with some kind of question or an expressed need. And once you think you have that relatively well formed and described, you need to make sure you understand everything you can about what's already known in this area. Now, this might mean reading a lot of literature. It might mean talking to existing experts or practitioners of different types, whatever. But as Isaac Newton said very famously some time ago, if you want to see further than others, you have to stand on the shoulders of giants. So you got to stand on the shoulders of people who've already worked on this problem. And I guarantee you, almost any problem you're going to encounter in trying to make a business process work better, other people have thought a lot about it and have done a lot of work around it. So then after that research the topic area, you get into a fuzzier part. Right? And these next three ovals, the hypothesis, the test, and the analyze there, the next three ovals interact quite a bit, right? And it's really about, I think, refining the original question based on what's really measurable or observable. In business especially, I think measurement is often very ambiguous. You know, for example, anyone can put out customer surveys and compute NPS scores, net promoter system scores. And then they can say they're measuring customer experience or customer delight. But what are you really measuring, right? You don't really know. And so when you try to interpret it and use it, you often end up going on a wrong path if you haven't thought deeply about what's observable and what's measurable. So you need to spend a lot of time thinking really hard about observability and measurement. You come up with ideas or hypotheses, you test them in the real world through all kinds of analyses and inference, and eventually you get to a point where you think you understand something. And you can make generalizations that can ultimately be used to make some kind of business process works better. Now, this goes over to the engineering side there again, which we're not going to get into here. It involves a lot of engineering once you get to that point, and involves a lot of change management, which is another area. So this we can, and actually developing trust within the business as well. So there's a number of other critical success factors you need to make this work, but I wanted to focus on the science part of it today. So one thing we don't want to forget about science that's very important, and that's different than I think commonly seen in data science context, is that science, generally in science, people are obsessive about openness and sharing and peer review, right? And also about welcoming criticism, even pretty strong criticism, as long as it's done in a good spirit. And things generally aren't believed until they're replicated. All right, so replicated by other researchers and other practitioners. So if you make a scientific advance, you have to describe it in pretty great detail and clarity, enough so that others can replicate your work and hopefully get essentially the same results. This kind of work hardening, you know, to use a metallurgical term, is what lets scientific advances build on each other to produce truly magnificent accomplishments of the kind we see around us every day, that are the results of hundreds or even thousands of years of science. Now, data science methodology over on the right is kind of similar, actually, right? You see here the CRISP DM methodology, which is very commonly used in data science. There's many variations on this, but they're generally pretty similar, at least from what I've seen. Not unexpectedly, the data science methodology is more data-centric than the science methodology. It tends to focus more on understanding and modeling the data as opposed to the physical phenomena per se, and we'll come back to that in a minute. So the methodologies are similar, but there are some pretty significant, important differences. As I just mentioned, science insists on an uncompromising kind of openness, right? You have to comprehensively disclose your work and subject it to formal peer review. You have to welcome the criticism of your peers and others. You have to enable others to replicate your work, and that's essential for progress. We don't really have this in enterprise data science, right? More often than not, in practice within enterprises, things are pretty opaque. Good documentation is pretty rare. Peer review is very uncommon. And it's often not a real strong confidence that things are right. In fact, data scientists sometimes I've seen act almost as something you might call big data bullies, where they'll tell you what the data say without letting you see for yourself all the innards of what was done and how it was shown and so forth. And if you disagree with them, you can be accused of not being data driven. It's almost like a shaman divining deep meaning in the data in mysterious ways that you have to trust but can never really get to understand. And science is different than that. It's not supposed to be mysterious. It's meant to explain clearly, ultimately, to anyone. So we'll come back to that point in a minute, but I wanted to use the cruise industry as an example for some of these. But also, before getting to that, let me go down to the other points there. Science, as I mentioned, has a focus on measurement and purpose-generated data, because enterprise data science generally uses the data that's already there. And in science, the team as a whole, not necessarily every member of the team, is knowledgeable about the relevant literature in the field and the best practices that apply to solving that kind of problem. In enterprise data science and AI, I don't think you find that. You often find incomplete and inconsistent approaches taken. There hasn't been a look at what's been done. Often the teams are staffed with people doing critical tasks that don't have a lot of experience and aren't using the best practices well known in the field and so forth. So I think that's something, again, and that is a result of the fact that there's not that critical peer review and that forcing of documentation and sharing and so forth. So as I said, I wanted to kind of talk a bit about the cruise industry as an example, because the cruise industry companies fit pretty well into this category of traditional enterprises that I mentioned earlier. So these are basically companies, and I think most companies in the world actually would fit into this category of traditional enterprises, basically companies that ran quite well prior to this modern age of data, so to speak, and have generally tried to leverage data and analytics in recent years in pretty much ad hoc ways that vary widely across the company in terms of depth and width and extent and so forth. So the most interesting enterprise AI problem areas, I think, are present in the cruise industry in especially interesting ways, as opposed to other industries. After all, we're pretty much a set of semi-independent, floating, self-contained cities coupled to an onshore full spectrum business operation, and this makes for lots of interesting complexity and opportunities. So for example, since cruise tickets are perishable, there's many complex problems around pricing sensitivity, inventory management, demand forecasting, and so on. We also run into what are essentially we also run what is essentially a large hotel and theme park. So there's all kinds of issues with staff scheduling, queue management, diversion, and so forth. We've got large volumes of customer data, so endless possibilities for understanding them better and making the experience better. And we also run a very complex dynamic supply chain with perishable cold items and all kinds of items that have to basically fill many ships every day, and so that's a major supply chain challenge. And these are just a few of the areas that we want to make more scientific. So we've got lots of data around this. It's one of the things that attracted me to the cruise industry, and we're constantly doing things to generate more data. I won't go through all the examples here, but in revenue management, for example, with my company, Royal Caribbean Group, we have 60,000 times a day people are querying for looking for a cruise. At any given point in time, we have 5 million different price points in the market. 50,000 cabins are for sale at any given point in time. We're making 120,000 price changes per week. 160 countries all over the world, 6 million guests in marketing, over 100 million records in our database with lots and lots of fields, 1,200 raw dimensions, many more when we do the feature engineering beyond that. 3 million outbound emails, a lot of promotional stuff, a lot of website interactions in the supply chain. You can see there, these numbers you see here are for one 7-night Caribbean cruise. 35,000 pounds of beef, chicken, or fish, 47,000 eggs, and you can go down. You can go down the list there. So there's a complex. Supply chain, right? But back to trying to look at, so we look at that data, we look at the problems we have, and we start asking questions when you want to get to this scientifically. So you start asking questions like, how do we best measure customer experience? I mentioned NPS before, right? That's one example that's not clear what it means. So how do you really measure customer experience? What can you observe? And how does that vary with the other key variables you can measure and outcomes that you want to track, right? How does food consumption vary by guest demographics and other factors? Can you predict how guests will flow through the ship and accumulate in different spots? And what kind of data do you need to do that? Can you apply modern consumer choice theory to quantitatively say what's the optimal promotional parameters you can get, and how does that vary by by demographics? Under what conditions can you measure price elasticity? What kind of covariates are needed to do that? And I can tell you an example. That's something we've spent a lot of time on. If you plot price versus volume, which is kind of what you would normally do to get an elasticity curve, it looks like a random scatter plot. So, it's not a well-posed problem. You need lots of other data. You need to bring in other kind of theories of what would drive that and so forth. So there's a lot of examples here. And, this is, how you go about starting to think about this scientifically. Now, I want to go back to the data-dominated versus scientific approaches for a moment. And to be clear, it's not an either-or situation. In fact, deep skills and experience in both approaches are super useful. And ideally, people can switch gears to operate in either mode as needed. But I think the distinction is important, right? So the data-dominated approach, kind of what you might call the computer scientist approach, or something like that, basically looks at the world as basically looks at a data set as the record of everything that has happened. It doesn't really think of the world as an external thing. The data set is the world, and it's a record of everything that's happened. So like all online customer transactions last month, all friendship links between members of a social network. And the goal of such a person working in this mode is to find interesting and stable patterns, rules, or relationships or associations between and amongst these data, right? And that's especially when the data get large, it's a very challenging problem, requiring a lot of specialized skill. But it misses something, and there's a reason why taking that approach hasn't been very successful with enterprise AI problems and haven't led to what we might call science of business. The scientific approach has a fundamental difference in that it sees the data set as a thin, partial, often very noisy reflection of some underlying phenomena that it's trying to study. So if you look back into physics, it's something like trying to understand how a star works just from getting the emission spectra, right? If there's a star, there's amazingly complex things going on in the star. All we get is the intensity of different wavelengths of light hitting us. But combining that with knowledge of nuclear chemistry and other things, you can end up, and people have ended up figuring out exactly how those stars work, right? So the data they got was a partial noisy reflection of the underlying phenomenon. They use other knowledge and other and scientific thinking to figure out what happens. And that's what we have to do, for example, to figure out booking volume at a given price, right? It's a very complex phenomenon. In the data itself that we have is not enough information to figure that out. So you have to do a lot of other things to make that work. Or NPS scores for ship sailings. You can model NPS scores and maybe come up with a weak predictive model, but you're not going to understand it deeply enough to actually engineer a better system to really make NPS go up. So in the scientific approach, the goal is a better understanding or ability to predict, often using mathematical models and different kinds of scientific thinking. Now, the danger of having too much data, or the danger of having too much of a data-dominated approach, rather, especially if the data aren't quite the ones that you need, was well summed up in a famous quote from Ronald Coase, who, if you don't know him, he was an economist. He won the Nobel Prize in economics in 1991, and he's actually a very interesting guy. He had only a small number of works, but they were mostly very important. Small number of works, but pretty much all of them were very important works. One of his most impactful works was called Theory of the Firm, where he develops a theory for why firms exist, what determines their size, and what determines what they do themselves versus what they outsource. Now, he was skeptical of relying too much on data and math and not enough on thinking about not enough about thinking scientifically about the problems at hand. And he famously said, if you torture the data long enough, it'll confess to anything. So in closing, I'd like to kind of conclude and say that the data are important. They're very important, right? I mean, we're all data scientists here. We love data. We live and breathe data. It's important, but you have to make sure, number one, that you get the data you really need. Don't just take the data that's lying around, which is what mostly happens in enterprise applications. You have to make sure you get the data you need, which means instrumenting business processes. It means making the case for people to gather different kinds of data they don't have now. It means sourcing external data that's not available to you currently. And to do that also, a big part of that is thinking and talking a lot about measurement and observability. In the way it's become very routine to scientists, we need to do that more, I think, in the enterprise AI area, to get to a science of business. And also you need to bring in all the relevant knowledge that you can, whether it's from practitioners, external experts, literature, whatever, plus rigorous methodical scientific thinking and analysis around that. And you need to do this in order to truly grow your understanding of a complex business process and the environment that it operates in, to ultimately be able to engineer and deploy new processes and tools that are going to work a lot better and continually improve. So with that, I'm happy to take any questions or engage in discussion or debate about any of this. Thank you.